Part B, they suddenly give you this information, which is about the derivative. So the strategy is obvious that you have to differentiate this and then compare with this condition and then try to solve the equation. You should able to solve lambda equal to 1/8. So part B1, x is equal to 4 and then plus 3k times 2 power of lambda t minus k power of -1. It's more convenient to use chain rule in this format. We are concerning dx dt. So 3k times -1, 2 power of lambda t minus. And then if it is too fast for you, then you may just simply write this one as a checkpoint, so you can just focus on this part later on. No rush, and accuracy go first. So 2 power of something, to differentiate we need to time natural log 2. After that we need to handle the derivative of the power, so only lambda is left, and don't forget the chain rule. So tidy up our answer. We are talking about -3k lambda, 2 power of lambda t, and natural log 2 divided by 2 power of lambda t minus k power of 2. So we find out the derivative, then we are going to compare with this given condition. So a little bit lazy, so just continue to write here. Negative natural log 2 divided by 24. X minus 4 and x minus 1 is something we already handled in part A. So you should check back your part A answer. Oh, this format is clear to understand, so we just simply write this one. 9k 2 power of lambda t over 2 power of lambda t minus k squared. There are several items that are both left-hand side and right-hand side appear, so we may just cancel out natural log 2. Okay, 2 power of lambda t. This troublesome bracket. Don't make everything being so messy. So after we cancel something, we may just simply copy down 9k and then remove the negative also. So 24 here. And then 3k lambda. Our target is lambda, so 9k over 24. Cancel out 3 to 24, that means 1/8. Lambda is equal to 1/8. We finish our target in B1 already. So after that, have a look at B2. B2, for each of the following condition 1 and 2, we also need to find k. Also determine whether the number of this will eventually become extinct or not. Extinct, that means x becomes 0. Is there any time will make x become 0? Is there any solution? It's give you the answer, extinct or not. If the answer is yes, that means finally it will become 0. We need to find the corresponding time. If the answer is no, then we need to find the number after a very long time. That means we are asking for the limit when the time tends to infinity. This is what we do. So, of course, you predict that this is exam and then they want to test your knowledge as much as possible. So, one of the case should be extinct, another case may not, do not extinct, and then we need to find the limit. But it's just guessing, okay? So, here, we already know lambda is equal to 1/8. So, we better update our information here. Replace lambda by 1/8. T/8 and then minus k. So still k is unknown. We want to know what is k. It seems like variation, they give you some k's and then you try to solve the equation. So condition 1, when t is equal to 0, x is equal to 0.8. We just put it in and then see whether we can solve the equation. 2 power 0 over 8 and then minus k. So this is negative 3.2. 1 minus k. So it's just some junior form equation. So we got k equal to 16 in this situation. And then don't forget we want to know, is that possible to be equal to 0? So we assume when before that, update the information first, otherwise no trouble. So 3k, that means 48, 2 power of t over 8 minus 16. We want to consider when x is equal to 0. Is that possible? So we're solving this equation. So this is two power of t over 8 is equal to 4. That means 2 power of t over 8 is equal to 2 power of 2. Compare the index. That means t over 8 is equal to t is equal to 16. So the answer is in this condition, if we extend, when t equals 16, after 16 years later. So now we already solved half of part B. We just exactly similar thing in condition 2. Condition 2, this time when t is equal to 0, x is equal to 7, much more than before. K is equal to, we don't know yet. We replace x by 7, replace t by 0. So 3k1 minus k. So k is equal to 1 over 2. Again, update the information. So 1 over 2 times 3 over 2. Will it extend or not? We try when x equals to 0 and see whether we have a make sense solution for that. So this is 2 power of negative 3. Compare the index. So when the time is negative 24, then it will extend. That means the number becomes 0. But of course, this is impossible. That's why we reject it. And then our conclusion is it will not extend. Based on the questions, if our answer is no, then we need to estimate the number after a really long time. So the number, we need to consider the limit when t tends to infinity. After a really long time, always mean limit when t equal to tends to infinity. So this one is follow this function, 3 over 2 and then 2 power of lambda 8 minus 1 over 2. So no matter how long 4 is still 4, and then 3 over 2 divided by infinity number minus something. Of course, this will become 0, but this is not correct writing method, so don't write this. In exam, you just simply write 4 plus, because it's divided by a really large number, so it returns to 0. You don't need to explain, but make sure you write down this step, replace this part by 0. Otherwise, maybe you lost some method marks. So this is 4. X will equal to 4. That means X will tend to 4 after a long time. Why I want to and plus that X tends to 4 is because what is X is the number in thousand. So when you answer should be 4,000. After a really long time. Be careful this kind of careless mistake. We're talking about 4 here, and that's why we always ask the student to check the corresponding unit, and we're talking about 4,000s.